The weight in pounds, W equal to F of D of an object varies inversely as the square of its distance in thousands of miles from the center of the earth. Okay, so you see the phrase varies inversely. W varies inversely as the square of the distance. Okay. So I have here the weight varies inversely as the square of the distance here. And then they tell us here for A, an astronaut weighs 220 pounds at sea level, about 4,000 feet, 4,000 miles from the Earth's center. Found an equation for F. Okay, so we're given initial conditions here. We have the W, we have the D, we don't have the K, but we can solve for K. So I'll plug in here, and I find that my K is 35,020. So my equation will look something like this. F of D, the same thing as the weight. Then B asked the question, how much would the astronaut weigh at 4,000 feet above the Earth's surface? So everything is relative to the center. So we have this from the center to the surface, and then from the surface, 4,000 feet miles above the surface. So we have 8 here. So in this case, D is 8. So we plug into our equation here, and we simplify it. It comes to be 55. So they're saying the weight is 55 pounds. At what distance would at what distance from the center of the Earth would the astronaut weigh 1 pound? So for that, in that case here for C, we let the weight, we set the W equal to 1, and we solve for D. So I get my equation for D here. D squared is equal to 3520. Then I take the square root of both sides, and I find what my D happens to be. So in this case here, D is equal to 59.33. But keep in mind, this is actually represents thousands of feet. So the actual value is going to be 59,000. So we have 59,030 miles. Because remember, the D is measured, it measures the number of thousands of miles. Yeah, now we move on to number D here. Estimate how much the astronaut would weigh on the surface of the moon. Okay. The moon's mean distance is about 239,000 miles from Earth. So they're looking at measuring the Earth's gravity from the distance of the moon. Okay, so D is 239. So we plug in here. So a person with respect to the Earth, the person will weigh this much. this many pounds, 0.062 pounds. Okay. That's the effect of the Earth's gravity on the person. And a model breakdown has occurred. Due to the Earth's gravitational field, it was almost of no effect. Number E, without finding an equation, discuss how an equation of a model of a 210-pound person would compare with the equation found in Part A. So for the E I have here, K was constant proportion over in A here. This K was derived using a weight of 220 pounds. So using a different weight here would give us a different constant, a different K. So we'd have different constant variations.